All right, welcome back to Renewable Rides. Today's highlight episode comes from our conversation with Charlie Marquez, Senior Manager of Environmental Health and Safety and Facilities at Kirkhill, an aerospace parts manufacturer here in Southern California. In this episode, Charlie walks through how what started as a simple cost-saving project, like LED retrofits and peak shaving with battery storage, evolved into something much bigger. Not because they set out to build a complex energy system, but because operational challenges forced them to rethink everything. You'll hear how a decision to modernize aging production equipment led to a fundamental energy constraint, one that couldn't be solved by just adding more power from the grid, and how that constraint ultimately sparked a creative solution combining combined heat and power, or cogen, thermal systems, solar, and batteries to support production without increasing electrical load. Charlie also breaks down the reality behind these projects, the 9 to 12 month iteration cycles, the internal hurdles, and the need to bundle multiple value streams, from energy savings to labor and quality improvements, just to get projects approved. And finally, we get into what it actually looks like to build a hybrid energy system in the real world. CHP, solar carports, battery storage, and dealing with the utilities, and why, in a place like California, energy projects don't just pencil, they become necessary. If you want a grounded, operator's view of how on-site energy actually gets done inside a manufacturing facility, this one's for you. Let's get into it with Charlie.
Energy has always been a challenge here in California, especially from a cost standpoint. And we just started looking at opportunities primarily for cost savings. And we did, in the early days, some of the most basic, we did the LED retrofit. We're a large facility. We're sitting on about 20 acres, about 400,000 square feet under roof. And so that's no small savings. I mean, that was a pretty significant savings, something like an 8-month payback with, pretty good annual return for something like that. We also brought in our first storage project that was primarily for peak shaving, third-party company called STEM, who has proprietary software. They put in a 500 kilowatt hour Tesla battery bank here that helped us manage our peak load here, and those are easy payback projects, no problem. And we had looked at solar and cogen at that point, and we were just like, those are big projects. Not sure we really want to tackle that right now. But then we kind of backed into that world because the driver for all that was operational excellence. We had some really old, antiquated equipment that was still getting the job done, but there were some quality issues, low yield, high manpower consumption, all that type of thing. And so we wanted to upgrade at least a portion of our plant. So we picked a pilot area that had some really old equipment, a lot of downtime, that type of thing, and decided that was going to be our pilot. I like to call it Kirkhill 2.0. And so we came in to an area that I'm sure your audience doesn't know how you cure rubber, but we cure it primarily here through heated compression molding. So you got a big press that has heated platens, and you stick a steel or aluminum mold with a bunch of rubber in it, and you squeeze it and hold it tight under heat, and that's how you cure the rubber. So we had a section here with about 30 of those presses that were previously heated by steam. Like I said, low yield, high downtime, high labor consumption. And we gutted that area completely, remodeled it, epoxy floors, new paint, all that stuff. And we're going to roll in some brand new presses. And the presses that we were looking at were electric heated versus steam heat. And so, first of all, that's a huge load on your electrical infrastructure, which we didn't have the infrastructure to support. And secondly, the ongoing operational costs of running electric versus steam was in California. Our Edison rep would have been happy. He probably would have, bought a new vacation home on that. But we just realized this is not going to work. So we started looking at all kinds of different ideas. First, and that's when we first revisited cogen. So we were looking at, CHP, and we have plenty of heat load here that we could utilize that heat for. But the reality is you're going to have this large capital expenditure and you're just going to offset a new electrical load. So that doesn't really pencil as a good project. And so we just kind of kept scratching our heads. And then, just kind of dawned on me one day, we did have a few of those compression presses here that are heated by not steam or electric, but with thermal fluid. Because with a flowing thermal fluid, you get a nice temperature profile. And it's really, really great for high yield. But it just dawned on me that, hey, what if we installed a CHP and used the waste heat from the CHP to heat thermal fluid? So there would be no new electrical load, and that we used the cogen to offset existing plant load. So reduce plant load, get free heat for the new presses. Now we're cooking. So, worked with a couple of different suppliers, crunched all those numbers. We actually engaged the DOE. They've got some free resources for CTAP, I think they call it, for CHP implementation. Also, our gas company has some free resources, and so they all vetted my numbers and my engineering ideas, and they said, I think it's going to work, and I think you could make this a viable project. And so that's the route that we went. And so we started that in 2021. Beautiful time to start a large scale project right on the tail end of a pandemic, with a completely jacked up supply chain worldwide. And so we're trying to bring presses from Taiwan. And so, yeah, it was a character building experience for sure.
Charlie, from the moment you started thinking about, we've got a mounting pain point, we've got an energy need that's going to increase, to starting to then vet the options, what was the time lag there? And then how long did it take you to go from there to feeling like we've got a good project and now let's go and execute on it?
9 to 12 months. Because we looked at all kinds of things. First thing we looked at, what would it take to bolster the infrastructure of our plant to actually be able to support this electrically. And then, as I mentioned, we looked at the implementation of cogen to offset the new load. And so each one of those is, to get a couple of different quotes and some engineering eyes on it is an iterative process. And so, each one of those steps probably took, 2 to 3 months, with some discussions in between. You got budgeting year overlap and that kind of thing. So yeah, it took probably the better part of a year before we actually had a design that we felt like was going to work.
What would the typical capital planning cycle look like? How far ahead are you typically expected to think for the business? And then what are your typical internal hurdle rates that you're looking for to make a good project?
Sure. I think we would typically plan, a year and a half or so out. I mean, we have a budget year, but something large scale like this, you'd probably identify it in the middle of the prior year, right? And so we already have an idea of what's coming up for the upcoming year. A typical project, that's where I think in California, it's funny, I've been to a lot of these energy conferences and all that, and people complain that energy projects don't pencil where they're from. And I'm like, yeah, that's because you're paying 6 cents a kilowatt hour for, your hydroelectric. I'm having a hard time feeling sorry for you. So those kind of things tend to pencil out a little bit better with our high cost of energy here. But I think typical manufacturing ROI, you're looking for something south of 36 months. But something that's going to deliver this kind of savings, somewhere, around $750,000 a year in savings, you get a little bit more leeway. So, we were able to put something together that was just a little over 4 years, but we did have to bundle difference. We had some labor savings. We had some quality savings, meaning we're going to scrap less material than we did before, along with the electricity savings. And all of those things bundled together, we're able to fund not only, not just the cogen, but also the new equipment and the new facility area. I think it would have been probably would have been a lot shorter payback just on the energy piece, but we were also buying new production equipment and renovating a portion of the plant, and it paid for all of that.
And were you ever experiencing any power quality or power outage issues as well that you could offset some sort of benefits against?
Not so much, except that we're part of a program in California called BIP, which is it's just the interruptible base interruptible program, I think is what it stands for. So we just we get a couple cent a kilowatt hour break on our bill, and in exchange for we'll reduce on in a pinch for Edison. And so two things. Number one, is if there is no interruptible event, they always have a practice event that you still have to shut down for. And it always ends up coming right at the end of our fiscal year. So that's a pain in the neck. And then we did have 1 year where we had several interruptions. And one of them came in on a Friday evening, and we didn't get the signal for it. And so we didn't shut down. So we ran through it at like 9x the normal rate. And so that was just incredibly expensive. So there's definitely some cost avoidance things that we were able to take advantage of. So, and also overall, we were able to reduce the steam consumption of the overall plant. So even our boilers are running at a lower rate than they were before. So there's all kinds of bundled savings. And so I think I even spoke at one of the SCD events about this whole idea of making sure you capture all of the possible savings there to make your ROI, appealing to those that are going to be approving it.
Yeah, there's many different value streams. Charlie, you've mentioned on as you've described this, the combined heat and power system. But I know from previous discussions that you and I have had, you've also have a decent sized solar array and then a battery energy storage system. Can you tell us a little bit about the specifics of the overall? I'll call it a hybrid energy system. How big are we talking? And walk us through the process of kind of, okay, we've identified that there's a project here. How did you go from that to okay, we're starting construction? Or all the way through to today?
Sure. So I think maybe we can talk a little bit later on a different question on the CHP. So that's, I know you and I have talked about the pain points of all of this. So
we'll come back to that.
Yeah. So the CHP we'll get back to that. So the CHP is a 1.3 megawatt quad microturbine unit. So there's actually 4 turbines, and that'll come into play for us because in all likelihood, we'll probably, especially when we get the solar online, be running 3 microturbines Monday through Friday and 2 microturbines on the weekend, just because of our fluctuating plant load. And so, but it's capable with all 4 turbines running to supply up to 1.3 megawatts. And then we're starting construction actually this week on our 750 kilowatt solar array. So I'm in the throes of relocating parking because we're doing carport parking, and so we've expanded one of our parking lots, and we're closing it a little bit at a time, and opening this gate at this time and closing this gate at this time. So it's a little hectic around here. We're all around that installation, and so we chose this time of year because we'll be closed for Thanksgiving and Christmas. And so there's a little bit of time when nobody's going to be parking here. And so we thought we'd take advantage of that. So we'll probably have that online and producing early springtime.
Excellent. And then the battery energy storage, is that still that STEM system, or is there
Yeah. So yeah, it's still, that's a leased system from STEM, though STEM has been quite helpful. We realize we're probably going to we're going to need to repurpose that, because the reality is we're not going to have any peaks here, and in 4 months or so we're not going to have any peaks to shave, and so we'll be exporting during daylight and importing minimal amounts in the dark, and so I'm sure there's a way we can utilize that, maybe to we'll have to make some decisions. So I'll be looking to collect some data and see how the performance of all that goes. And so right now we're planning to run it in a semi-manual mode, right? The solar is just going to produce. We've got some smart controls on there that will just export when available and import when necessary. But I'm sure there's some ways as we move forward and mature that we'll be able to utilize all of those assets, in conjunction with one another to maximize each one of them.
And Charlie, I was going to ask why, what prompted the solar array? I mean, 750 kW is a good sized system, and one that's a solar carport at that. I mean, I think oftentimes people hear solar canopies or carports, and that is the most expensive form of solar. But what drove the decision to include that in your system?
Yeah, I think again, even with the CHP, we still weren't supplying all of our electrical needs, and with the high cost of electricity, and we were able to get in on the tail end of NEM 2.0. So with the ability to export at full retail value, there's and knowing that we would be still importing from the grid in the evenings and being able to offset that. So basically, not completely eliminating our bill, so to speak, from Edison. I think that still made sense. And so, yeah, I think for us, it's not really an option. We're in a building that was built in the 1940s. And I call it a building loosely because it's not a building. It's a series of 15 Butler buildings kind of stacked together. So if you look at our building on Google Earth, especially if you do the old tilt feature on Google Earth, you'll realize our rooftop looks like the Swiss Alps. Just goes up and down, up and down, up and down. And it's littered with skylights, which are a great feature, but solar panels, well, first of all, it's a tin roof that I just put a $750,000 foam cap on for insulation and water resistant reasons, and it's been wonderful for that. Certainly lowered the summertime temperature in the whole building, so that's great. But I didn't want to go punch 1,500 holes in it with solar panels. And secondly, I'm not sure we would have got a permit to do so on that type of construction. And then thirdly, you have to be so far away from the skylights that it would have been a bit of a nightmare on installation. The thing would have ended up stringing across so much of our roof. It just didn't make sense. So it was either carport or nothing.
We receive a lot of questions from business leaders around the world wanting to learn more about the energy transition, what is possible, and where to start. So to help you stay informed and up to date on best practices, opportunities, risks, and success stories, we created an industry newsfeed at VECKTA.com/news with all our podcasts, blogs, and newsletter. Check it out and connect with Dan, myself, and the VECKTA team to learn more. Cheers and have a good one.